This session is about fructose metabolism. Fructose, it is a ketoexose. So, it is a ketoexose and also a functional isomer of glucose. Ketoexose means it has a functional group of ketones. Next, it is present in fruits, honey, corn syrup and sucrose. Sucrose is a non-reducing disaccharide containing glucose and fructose. This is free fructose is seen in large quantities in seminal plasma. So the semen contains fructose because the sperm mobility requires fructose for its energy. So like I said, the sucrose contains glucose and fructose. It is a non-reducing disaccharide. So most common source of fructose is sucrose. So if this is the intestinal cell, when we eat food, the sucrose reaches the intestinal cell. It is acted upon by sucrase to produce glucose and fructose. Glucose enters the blood circulation by glucose transporter 2, whereas the fructose enters the cell by glucose transporter 5, which enters the blood circulation. So the fructose transporter here is glucose transporter 5, GLUT 5. Once it is absorbed, it is taken into the portal circulation to the liver for its metabolism. The fructose has two pathways. One, it can be converted to fructose 6-phosphate, otherwise to fructose 1-phosphate. How it is converted to fructose 6-phosphate? First, we'll see that. So, fructose to fructose 6-phosphate, you are going to add one phosphate group. That means the enzyme here is kinase, exokinase. This is also the enzyme for glucose to glucose 6-phosphate in the glycolysis. So, when you are requiring a exokinase, it needs ATP, which gives the phosphate group to the substrate, and also it requires magnesium. So, the kinase requires ATP and magnesium. Fructose 6-phosphate is then converted to glucose 6-phosphate by an enzyme called isomerase because these two compounds are functional isomers. What happens once a glucose 6-phosphate is produced? It has many fates and mostly it goes into glycolysis. Okay. So it goes into glycolysis. So we have seen the first pathway. What is the second one? Fructose to fructose 1-phosphate. For that reaction also, you are going to add a phosphate group from ATP. Okay, it requires magnesium for its activity. The enzyme here is kinase, but it is a fructokinase. This fructokinase do not require insulin for its activity. When fructose 1-phosphate is formed, it can divide it into two compounds, okay, by an enzyme called aldolase B. So the compound which is formed here is dihydroxyacetone phosphate and glyceraldehyde by the enzyme aldolase B. You have seen a similar enzyme in glycolysis, that is aldolase A. Okay. The glyceraldehyde further converted to glyceraldehyde 3-phosphate. Here you are adding one phosphate group. That means the enzyme here is kinase. How many carbon? 3 carbons. So it is triose kinase. So all the kinase reaction require one ATP and magnesium. What happens once the dihydroxyacetone phosphate and glyceraldehyde 3-phosphate is formed? They are isomers. Okay, they are isomers. So they can be formed by isomerase. These two compounds join to form fructose 1,6-bisphosphate by the enzyme aldolase. fructose 1,6-bisphosphate can enter into the gluconeogenesis pathway and can form the glucose. Otherwise, this glyceraldehyde 3-phosphate alone can form the glycolysis end product, that is pyruvate. What is the fate of dihydroxyacetone phosphate? It can give glyceraldehyde 3-phosphate. Otherwise, it can give glycerol, which is used for synthesizing triacyl glycerol. So, when we take food rich in fructose, it leads to the formation of triacyl glycerol because the fructose is rapidly utilized. So, it can build up the triacyl glycerol formation very fast.